Thanks very much for that introduction. How's the volume on the mic? Okay, good. I'm going to talk just very briefly about myself. I work at a small liberal arts college, which is a kind of institution that I imagine some of you are not familiar with. We have 3 computer science faculty, no graduate students. My job is primarily teaching, but with a little bit of research. And I mention that only because I'm very interested in any sort of collaboration. In case anything I say here is interesting to anyone, I'm super happy. I don't need much research credit for my job, so I'm happy to give that away. I'd much rather see these ideas come to fruition in some sort of way. These are lovely pictures of Colorado. Also, I came to security and privacy relatively late in my research life, so if you think I'm missing anything, I'd really love to hear about that. Okay, so my goal is to make an architecture for building collaborative editing applications. These kinds of applications, of course, are very popular and useful for helping teams work together, play together, do all kinds of things together. But the way that almost all of these applications work in the world today is that the service provider has all your data. And I don't think it'll take much convincing in this crowd for me to say that this is kind of a problem, that the company, all their employees, malicious hackers, governments can get at your team's data pretty easily. This is not a great state of the world. So my goal is to enable those kinds of applications, nothing new there, but with better security and privacy. Step 1 is an idea that's been explored in a couple of research projects, and then I'll go into something a little bit new after that. So step 1 is to take the plain text data, the database, the document, whatever it is, and move it from the central server to the clients. And then the clients broadcast the edits to each other instead of sending them all to the central service to be integrated into a single document. And of course, we use some sort of end-to-end encrypted protocol for this, and you can use whatever your favorite end-to-end encrypted messaging is. And this sort of shape of idea is something that's been explored a couple of times. As far as I'm aware, there aren't any really widely deployed systems that use this. And I'm going to have a little bit of speculation later about why that might be the case. And technically, what I'm focusing on in my project is getting rid of this central server entirely. And why do I want to do that? Well, first of all, it makes metadata collection really easy. Nobody likes metadata collection. Second of all, it's relatively easy to block some sort of central service. So I'm thinking here of things like Telegram in Russia and Signal in lots of countries where somebody is trying to block the use of a service. It's relatively easy to do when there's some sort of central service provider. And then for the litigating part, I'm thinking about things like key disclosure laws. After the GDPR presentation this morning, I'm a little less confident that decentralizing the service actually means something legally, but I don't know. I'm not a lawyer. And then just expounding on those 2 ideas a little bit, in some sense, if you have somebody trying to run a collaborative editing system in this secure and private way, where they're providing the central infrastructure, they get kind of the worst of both worlds. They don't get the user's private data to sell, which of course is what a lot of them want, but they still get the cost of paying AWS or whoever it is, and whatever risks there are associated with having people's data, even if it's only in an encrypted form. Okay, so how do we decentralize this? Before I talk about my technical idea, I just want to talk a little bit about the kinds of users and uses that I'm imagining, because I think there are lots of ways that you could try to attack this, and so I'm going to try to motivate the particular way I'm going at it. I know that many people here think a lot about users with heightened privacy concerns, and that's not what I'm interested in so much. I'm more interested in old people and Luddites who just want to use the internet in a, maybe sensitive, maybe not so sensitive kind of way, and I don't like that, Google and the government and everybody is vacuuming up all this data. So that's the main group I'm thinking about. I can hear some of you rolling your eyes at me because, of course, regular people don't care about privacy, and fueling my hope just a tiny bit. This is a different area, of course, but this is a graph from Let's Encrypt, and they made it almost as easy to do HTTPS as HTTP, and hey, lo and behold, more HTTPS. So I'm hoping that if good, secure, and private collaborative editing is just as easy as the regular kind, then hey, maybe some people will shift over to that. So based on those assumptions about the kind of uses and users, I'm thinking about what does that mean technically. So it means two things for me. One, I'm assuming that these users have some kind of client computer. I'm not yet thinking about what if you only have a feature phone. That's for future work. Everybody's got a computer, but they might be connected to the internet only intermittently. So a protocol where we're assuming they have some kind of online communication for sharing the data is not going to work for what I'm trying to do. We need something else in the system to store the data for the users to communicate with each other. So the other piece that I'm assuming is that they have some kind of commodity cloud storage account. And so then the users are going to upload their edits, encrypted of course, to their own commodity cloud storage account, and then their teammates will monitor everybody else's cloud storage account to get those edits and then integrate them into their own copies of the team's database or document or whatever it is. Okay, now just super briefly, what are the biggest technical challenges that I've come across in trying to implement this? The first one is concurrent editing conflicts. Of course, in any decentralized system, you can run into concurrent editing conflicts. And so the way I'm trying to solve that is that the core data model is that each user has their own chain of edits they've made to the team's data, and they upload that to their own cloud storage account with some sort of distinguished root file pointer. And then everybody else is responsible for monitoring those, and then there's some sort of atomic broadcast protocol that I'm still working on to hopefully get everybody to agree on how those edits should be interleaved in time. This is kind of classic distributed systems stuff, but my assumptions about the system are a little bit weird. This is pretty different from like normal database replication in warehouse computing and that kind of thing. So sort of classic, but with a little bit of a twist. And then finally, when I talk about the data model being this accumulation of little edits, some of you might be worrying, oh, that's going to be really limiting, like Bitcoin, which is accumulation of little edits, but the data model there is very limited, or really inefficient. If you just have a simple log file where you accumulate data, then querying that later is going to be super inefficient. I'm using this cool little database called Datomic as my model, which is engineered from the ground up to deal with this sort of accumulation of little edits model, but it does a very general purpose database that actually has pretty good efficiency properties in most cases. So, in summary, my goal is to make an architecture for collaborative editing systems that allow you to do any kind of collaborative editing that you want, but with better security and privacy than current systems. The key idea is that users broadcast chains of edits to each other by uploading to their own commodity cloud storage account. And then there are a handful of technical details that are a little bit gnarly that need to be ironed out along the way. And my current prototype is some of the way towards implementing this. I'm not done, but seeming reasonably feasible so far. So thanks for your attention. And I was told to prepare suggested discussion questions, so.
Great, thanks. We'll take questions now.
So there are two possibilities. Why couldn't you use something like SpiderOak and a joint account that doesn't do the simultaneous editing nicely? It does do editing, but each person. So SpiderOak, the keys are on the client device. They're not data is stored in the cloud encrypted, and so. And then as you were talking, I looked up, and there's a product out of Switzerland that has good reviews that seems to do the thing you want, Treesort. Have you looked at it? I don't know anything about it. I've been using SpiderOak for a long time.
Did you say Treesort?
I've been using SpiderOak for a long time and been happy with it.
Okay.
Treesort, Tresorit.
Yeah, super coincidentally, I actually met one of the founders of Treesort in Hungary.
Okay.
So, to the best of my knowledge, Treesort is really pretty conventional file storage. And so I'm not aware that they can do a more fine-grained kind of application, but I might be wrong about that.
Okay. But SpiderOak, you could do it.
Yeah, I'm going to have to look into that more.
So SpiderOak is worth looking at. Now
Okay.
they don't directly support editing, but of course you could do that way. You could do the editing if you're not planning for simultaneous editing. If you're
well, I do want to support simultaneous editing for sure.
literally simultaneous.
Literally simultaneous.
Okay.
Yes. Yeah. Part of the atomic broadcast protocol is that there can be simultaneous edits and then they get merged.
Hi. We've done some work in this space. So we have a demo of Trello working in this editing kind of mode. So we should perhaps catch up after your talk to talk in detail how that works. So conflict-free replicated data types is like another alternative algorithmic solution in this kind of space, which is what we've been exploring, which is, I think, complementary to your kind of system.
Yeah, CRDTs are interesting, and I don't know if I just have not thought creatively enough about them, but they feel somehow limited to me, that you can make a set or a map or whatever, but that's not a complete application. So I'd be very curious to talk about.
Sure. So we support basically JSON, so you can have nested lists of maps and lists of maps, maps of lists, and so on, and then represent text as a ordered list of characters, that kind of thing. Anyway, we can catch up later.
Yeah, just in case anyone is curious, the thing I get hung up on there is that if you define that protocol for how to do the merging at the system level, then you leave out the application semantics. And so, okay, you've got a set, but if you're merging the set, do you really want to put both of them in there, or do you want to define that as a real application semantic level conflict? And so the system that I'm working on, each transaction can have a precondition, just a totally arbitrary function, and when the users are then trying to merge them, that can fail. So anyway.
Sure. Okay.
Hi, great talk, by the way. And this reminds me a lot of good old CouchDB. I don't know if you heard about it, and their model of like having a database on each of your devices and all of that. And so one of the problems that when I was considering using CouchDB was how do we broadcast if, for example, I make an edit, but then I'm offline for a while, and then you make your edit, and then you're offline for a while, and then I make another edit, and like when do we synchronize? For example, if we have 3 separate devices, like chances are that we don't like at the same time be together for like a long time, for example.
Yeah, so the way that my prototype system is working is that users upload their own edits to their own cloud storage. So you can work offline if you want, but then of course you're not going to be synchronizing with anyone. And then you upload your edits, and then there's a kind of implicit obligation. I'm assuming that within a team, people are working cooperatively. There's no adversariality within a team. And when you go online, you're obligated to download your teammates' edits before you try to upload your own. And so then you have an opportunity to see if there are any conflicts that have arisen there. Does that answer the question?
Yeah, definitely. But isn't that like if you are uploading it to a cloud storage, are you not centralizing it somehow? Because then even if it's your own storage, like you're depending on a central server somehow of sorts, right?
Yeah, for sure. There are definitely interesting questions about how much the system trusts the cloud storage. Of course, everything is encrypted and signed, so without breaking that, they don't get the team's information. But it would be trivial for the cloud storage provider to do denial of service, and they could try to be fancier about that and just make little modifications or whatever. And that's true. So it's possible that piece of the decentralization. I'm not sure how much it buys you, or I'm not sure what scenarios exactly it buys you a lot in. I have worked to keep the sort of API between the storage API extremely simple, so it wouldn't be conceptually very hard to go to some sort of crazy P2P cloud storage something or other if you were concerned about an attack from the cloud storage provider.
Okay, thank you.
Hi, thanks for the talk. We actually also have worked a little bit on the topic, and the one issue which we faced, or the challenge which we found the most difficult, was access control. How do you remove people to the team or add them? Have you looked into it already, and do you have any ideas?
Yeah, the only thing I've done so far is quite simple, which is that so the meta information about who's in a team is part of the team database itself. And as you invite new people to the team, that gets updated, and anyone can remove someone from the team whenever they want to. And effectively, that just forks the future of that team, and they will no longer make their edits available to those users. And the other people on the team can agree with that or not. And it could get messy, potentially, but anyone can choose not to give the necessary keys to anyone else if they want to remove them from the team.
But essentially, all your updates are one-to-one. So you encrypt the same, like, edit for every single member of the group, right?
Yes. Yeah. Technically, you upload each edit once with a symmetric key, and then send that key to each of your teammates with a different. Yeah.
With a accumulate-only data model, how does write to erasure works? It seems like even if all of the participants in the centralized system are like honest and so on, they can't delete stuff. Isn't that like scary?
Oh, so you're worried about the kind of the database model, and it's this accumulation, and data never goes away. It is possible to expunge data from the database, and that just means you've got this chain, but underneath it's really a tree. And it is possible to actually remove something. You need to add another transaction on the tree that says delete the data from transaction N, and then it makes a new tree that is then missing that data. It's a little, performance-wise, it's not great, but it is possible to actually remove. It's not the default operation mode, but it is possible.
About 5 minutes left for questions. I'd like to ask a question, actually. You have this performance bullet point here. Okay. And so when I think of collaborative editing, that seems to encompass a lot of different kinds of scenarios, some of which are like maybe these last-minute group of people working on a project, but it could also be longer-term maintenance of some shared collaborative resource. Do you have any thoughts on maybe what types of things this would be used for, or kind of like different scenarios that would require different performance?
Sure, yeah. In the short term, where the cloud storage is the only medium for communication, that definitely puts a limit on the performance. Getting something up to Google Drive or Dropbox or whatever, and then somebody else observing that is optimistically around a second and can easily be like a minute. So we're definitely not talking about low latency sorts of applications with that infrastructure. So the kinds of applications that I've been imagining, so for the first one is a chore recorder where a family or a team or whatever can get together and say, hey, we want to do these things, and you just click a button and say, hey, I walked the dog, or I did the dishes, or whatever. Or keeping a calendar or an address book amongst a team is a similar one where latency is not especially critical. I thought a tiny little bit about using WebRTC if two users happen to be online simultaneously, and using that as an alternative communication mechanism, but I've not implemented that at all yet.
Cool. Any other questions, comments? I know there's ice cream next. We were talking about maybe you have to ask a question before you get ice cream.
That doesn't count.
What's your favorite flavor, though?
What's my favorite flavor? Let's go with mint chocolate chip.
Okay.
All right, thank you.